Okay, so we can use these three equations and we can convert some polar equations to Cartesian equations. Let's start with r cosine theta equals 2. Okay, well, this is pretty simple because since x equals r cosine theta, then x just equals 2. So that's just the vertical line x equal 2. All right, let's take a look at this one. R squared cosine theta sine theta equal 5. Okay, well this one's pretty simple too, because if you break this up into r cosine theta times r sine theta, well, r cosine theta is x and r sine theta is y, so that's just xy. So basically the left side of this equation is just xy and the right's 5, so that's just the hyperbola x equal 5. And then this one, since that's r squared cosine squared theta and this is r squared sine squared theta, then this is just x squared and this is y squared. So you have x squared minus y squared equals 1 for the Cartesian coordinate, or for the Cartesian equation. Okay, now some of them can get a little bit more difficult, as you can imagine. Okay, so let's take a look at what we have to do to convert this one to Cartesian coordinates. Okay, well, we know that r, if we go up here, we know that r is the square root of x squared plus y squared, and x is r cosine theta. So we can actually replace r with this, and then we can replace r cosine theta with x. So we get the square root of x squared plus y squared equals 1 plus 2x. Well, then let's square both sides to eliminate the radical. So if we square this side, we just get x squared plus y squared. And if we square this side, we're just squaring a binomial, so we'll get 4x squared plus 4x plus 1. Now, if we move everything to the other side, you'll get x squared minus 4x squared is minus 3x squared. So move the 4x over, you get minus 4x. The y squared is going to be over there, and then move the 1 over and you get minus 1. So this actually would be the equation. Obviously, if you want to get rid of the negative 3x squared, you can multiply everything by negative 1. So there you go, there's that one. Now, what about r equal 1 minus sine theta? Okay, well, r equal 1 minus sine theta is actually the same as r squared equal r minus r sine theta. All I did was multiply both sides by r. And what that did is that allowed me to have an r squared here, so I can replace r squared with x squared plus y squared. I can replace r with square root of x squared plus y squared. And then I can replace, see over here I had a sine theta, but now that I have an r sine theta, I can call that y. So I actually have minus, let's see, something's off there. Give me a second. Okay, I got it corrected now. So this should be r equals 1 plus 2 sine theta. So let's convert 1 plus 2 sine theta, r equals 1 plus 2 sine theta, to Cartesian coordinates. Now again, I'm going to multiply everything, both sides, by r. So that'll give me r squared equals r plus 2r sine theta. Well, r squared is x squared plus y squared. R is the square root of x squared plus y squared. And 2r sine theta is actually 2y. Now, so what I'm going to do is I'm going to move this 2y over here, and then I'm going to square both sides. So if I square this side, I just get x squared plus y squared. Now, if you square this side, you're going to have to square a trinomial, so you might want to multiply that out long ways. But basically, when I did, I got this long polynomial expression involving x and y. And then if I move the x squared and the y squareds over, I actually get a minus x squared, and let's see, where did my minus y squared go? Oh yeah, I had a 4y squared here, right? So when I subtracted the y squared over, I'm left with a 3y squared. So basically, so like I said, some of those can be rather nasty. In a similar fashion, you can show that r equals 1 minus cosine theta is this if you want a practice problem. I'll go ahead and convert a couple of Cartesian equations to polar equations. You know this is a circle, x squared plus y minus 5 quantity squared equals 25. Let's go ahead and square the y minus 5, and we'll get y squared minus 10y plus 25. Then when you subtract 25 from both sides, you get a 0 here. So we have x squared plus y squared. Now remember, that is r squared. So x squared plus y squared gets replaced with r squared. And then remember, y is r sine theta. So we get r squared minus 10r sine theta equals 0. But actually, we can divide all these terms by r, as long as r is not 0. And we get r minus 10 sine theta equals 0. So r equal 10 sine theta is a much nicer form than leaving it like this form. So r equal 10 sine theta is actually a circle with the center at x equals 0 and y equal 5, and with radius 5. Okay, now this is just a line. So what I'm going to do here, I'm going to rewrite this with 2x and y on the same side. So here I have 2x minus y equal 5. And you can probably manipulate this yourself without me going through that. Okay, now we know x is r cosine theta and y is r sine theta. So I have 2r cosine theta minus r sine theta equal 5. And then if you factor the r out, you get r times 2 cosine theta minus sine theta equal 5. And then if you solve for r, you get r equals 5 over 2 cosine theta minus sine theta. Now here's a practice problem you can try, and you can try to convert this Cartesian coordinate to polar coordinates, and you should get, for that equation, you should get r equal 4 cosine theta. Now, before I let you go here, let me give you a little bit of insight into what you might see later, I believe, probably if you get into a Cal 3 course. Okay, so let's say you wanted some three-dimensional coordinate systems other than your basic x, y, z rectangular type. Well, there's actually a system that's similar to polar coordinates, but it adds a third dimension called cylindrical coordinates. And there's another set of coordinate system that you can use called spherical coordinates. So if you want, you can Google those. I'm not going to go over them now, but I just thought I'd mention them since I have a little bit of time left over on this video. And again, these are used for when you're graphing in 3 dimensions. Okay, that's the end of this lecture, so let me shut her down.